So today's topic is tests of divisibility. Tests of divisibility is a very important topic for quantitative aptitude. What is a test of divisibility? A test of divisibility checks whether a given number, any given number, is divisible by another number. For example, is 303 divisible by 3? Is 512 divisible by 8? Is 1302 divisible by 11? And so on. So if I give you two numbers and ask you whether one number is divisible by another, you should be able to figure it out whether it is divisible or not. So there are some basic tests of divisibility. So let us look at the first test of divisibility, that is divisibility by 2. This is the easiest. If the number is even, it means the number is divisible by 2. So the units place should be even. Even in the sense the units place can be 0, 2, 4, 6 or 8. So is 46 divisible by 2? Yes, because 6 is even. Here 722, 2 is even. In 863, 3 is odd, so it is not divisible by 2. 988, 8 is even, so it is divisible by 2. Next is test of divisibility for 3. For 3, the sum of digits should be divisible by 3. What does that mean? So is 48 divisible by 3? So 4 plus 8 is 12. 12 is divisible by 3, hence 48 is divisible by 3. So the sum of digits, if it is divisible by 3, the number itself is also divisible by 3. Is 212 divisible by 3? So let's see. 2 plus 1, 3, 3 plus 2, 5. 5 is not divisible by 3. So 212 is not divisible by 3. 363, 3 plus 6, 9, 9 plus 3, 12. 12 is divisible by 3. So 363 is divisible by 3. Now we have a slightly bigger number. So 4 plus 2, 6, 6 plus 3, 9, 9 plus 1, 10, 10 plus 5, 15, 15 plus 2, 17. 17 is not divisible by 3. So this number is not divisible by 3. So this is a test of divisibility. The sum of digits should be divisible by 3. Next is divisibility by 4. You only have to check the last two digits. The last two digits should be divisible by 4. So is 484 divisible by 4? For that you have to look at the last four digits. Yes, 21 into 4 is 84. So yes, 484 is divisible by 4. So you need to know table of 4 up to 25. There is no other way. Is 168 divisible by 4? Yes, 17 into 4 is 68. So 168 is divisible by 4. Is 420 divisible by 4? 20. Last two digits. 20 is divisible by 4. 4 5s are 20. So 20. So 420 is divisible by 4. And then we have a slightly bigger number, but no issues. We only have to focus on the last two digits. 52. Is 52 divisible by 4? Yes. 13 into 4 is 52. So this big number is divisible by 4. Next is divisibility by 5. This is very easy. The last digit should be 0 or 5. Then it is divisible by 5. 485, yes. 250, yes. 423, no. This big number is there, but then the last digit is 2. So it is not divisible by 5. Divisibility by 6. The number should be divisible by both 2 and 3. Okay, understand, both, not just one, but both 2 as well as 3. So let's check one by one. 72, is it divisible by 6 or not? So test for divisibility for 2 is that the units place should be even, and here it is 2, it is even, so it is divisible by 2. Sum of the two digits, 7 plus 2 is 9, 9 is divisible by 3, 72 is divisible by 3. This number is divisible by both 72 as well as by 2 as well as 3, hence it is divisible by 6. Next, 256. So yes, the units place is 6, so it is divisible by 2. Then add the digits. 2 plus 5, 7, 7 plus 6, 13, 13 not divisible by 3. 256 not divisible by 3. Thus the number is not divisible by 6. 313, well, 3 is an odd number, so it is not divisible by 2. Similarly, we have this big number, but it is not divisible by 2 since the units place is not divisible by 2. Okay, so this is the divisibility test for 6. Divisibility test for 8. So you have to divide the number by 2 3 times. You have to half the number 3 times, and you should still get a whole number. Let us see an example. Is 485 divisible by 8? So you have to divide this number by 2 3 times. Now, as you might have observed, it is an odd number, so you can't divide it by 2. So this number cannot be divided by 2 even once. So this is not divisible by 8. Let's move on to the next. 250 divided by 2, you get 125. You have divided it by 2 once. Divided by 2 again, 125 divided by 2. You cannot divide it further. So you can divide it only once. So this is not divisible by 8. You should be able to divide it thrice. 256 divided by 2, you get 128. Divided by 2 again, you get 64. Divided by 2 again for the third time, you get 32. So 256 is divisible by 8. Now we have a big number, 786152. The good thing is you need to only focus on the last 3 digits. 152. You need to find out if 152 is divisible by 8 or not. If it is, then the whole number is divisible by 8. So that makes it easy. 152. So divided by 2, you get 76. Divided by 2 for the second time. 76 divided by 2, you get 38. Divided by 2 again, you get 19. So you can divide this by 2 3 times. So 152 is divisible by 8, and hence this whole number is divisible by 8. Divisibility by 9 is similar to that of 3. Even here the sum of digits you have to consider, and it should be divisible by 9 instead of 3. So it's 666 divisible by 9. 6 plus 6 plus 6 is 18. 18 is divisible by 9. So yes, 666 is divisible by 9. What about 363? Well, 3 plus 6, 9. 9 plus 3, 12. Not divisible by 9. 333, yes, 333 will give you 9. It is divisible by 9. And then this number. What is 7 plus 8? 15 plus 6, 21 plus 1, 22 plus 5, 27. 27 is divisible by 9. Okay, now what if you add all the digits and you still get a big number and you don't know if it is divisible by 9? Apply the rule again. Again add the sum of that digits of that number and then see if it is divisible by 9 or not. Okay. Divisibility by 10, this is the easiest. You just have to look at the last digit. The last digit has to be 0. So this is 6360 is divisible by 10. 360 is divisible by 10. 333 not divisible by 10. And this big number, yes, divisible by 10. Next, divisibility by 11. So this is a bit tricky. The difference of sum of alternate digits should be divisible by 11. What does that mean? The sum of alternate digits. So 6 and 5 are alternative. So 6 plus 5 and 8 plus 3. So 6 plus 5 is 11. 8 plus 3 is 11. Subtract 11 minus 11. You get 0. 0 is divisible by 11. 0 is divisible by any number. So yes, 6853 is divisible by 11. Let us see a smaller example, 121. So alternate digits 1 and 1, right? 1 plus 1, 2, and this is here alone, so 2. 1 plus 1, 2, and the alternate digit is 2, so 2 minus 2, 0 again, divisible by 11, so 121 is divisible by 11. Let us try for 319. Again same, 3 plus 9, 12, and 1. So 12 minus 1, 11. 11 divisible by 11, yes. So 319 is also divisible by 11. And the final test in this video is test of divisibility by 12. The number should be divisible by both 3 and 4. So this is similar to 6. In 6, the number should have been divisible by both 2 and 3. Here it should be both 3 and 4. So is 144 divisible by 12? So test for divisibility for 3 first. 1 plus 4 is 9. Yes. So 9 is divisible by 3. And Test for divisibility of 4 is last two digits, 44. Yes, 11 into 44 is 44. 11 into 4 is 44. So yes, 144 is divisible by both 3 and 4, and hence it is divisible by 12. What about 1322? So add the digits 4, 2 and 2. 1 plus 3 is 4, 6, 8. Not divisible by 3, so not divisible by 12. Then 3 to 4. 3 plus 2, 5. 5 plus 4, 9. Yes, it is divisible by 3. And 24. 24 is divisible by 4. 4, 6 are 24. So yes, 324 is divisible by both 3 and 4. Hence it is also divisible by 12.